Bye-bye, Tetrad. Welcome to Stargazers. I'm Dean Regas, astronomer from the Cincinnati Observatory.
And I'm James Albury, director of the Kika Silva Pla Planetarium in Gainesville, Florida. Next week, we get to experience the fourth and final total lunar eclipse of the 2014-2015 Tetrad.
You might be asking yourself, what's a tetrad? Well, they're very rare, and in this week's episode, we'll tell you why.
We'll also give you the lowdown on the September 27th lunar eclipse. Let's show you. Here's how eclipses work. Celestial bodies cast two shadows, a darker inner shadow called the umbra, and a lighter outer shadow called the penumbra. Your location with respect to these shadows will determine the kind of eclipse you can see.
The geometry of the lunar eclipse is quite simple. First, the moon must be in the full phase, putting the Earth between the sun and moon. When the Earth, moon, and sun align perfectly, we get eclipses.
Because the moon's orbit is tilted by about 5 degrees with respect to the Earth's orbit around the sun, the Earth, moon, and sun rarely align. However, when they do, the moon passes through the Earth's shadow.
Since the Earth is so much larger than the moon, our entire shadow can cover the moon. How high above or below the Earth's shadow the moon passes determines the type of lunar eclipse we can see.
If the moon only passes through the Earth's penumbra, we have what's called a penumbral lunar eclipse. This causes only a slight dimming of the moon and is almost unnoticeable to the average moon watcher.
If only part of the moon passes through the Earth's umbra, the darker inner shadow, we have what's called a partial lunar eclipse. This causes a noticeable darkening of a portion of the moon's surface.
However, if the moon passes completely into the Earth's umbra, we have a total lunar eclipse.
Now, if you remember, 6 months ago we had a total lunar eclipse on April 4th. Well, it may surprise you to know that there is an almost 6-month pattern for eclipses. We call these eclipse seasons. The moon's orbit around the Earth is tilted, appearing almost like a dinner plate that is tilted with respect to a dinner table. The points of intersection between the moon's orbit and the plane of the Earth's orbit are called the nodes. If the new moon and full moon occur when the moon is at one of these nodes, we get an eclipse.
As the Earth orbits the sun, it carries the moon with it. These points of intersection allow the sun, moon, and Earth to align at almost 6-month intervals. So, for example, in April 2014, the new moon and full moon were aligned with the sun and Earth, and we experienced a total lunar eclipse, and 2 weeks later, there was a solar eclipse.
If we advance time 6 months to October, the new moon and full moon again aligned with the sun and Earth, and on October 8th, we saw another total lunar eclipse. And 2 weeks after that, on October 23rd, there's a partial solar eclipse.
Although the 6-month pattern of eclipses happens rather frequently, it's rare that you get 4 total lunar eclipses in a row. We call this a tetrad. A tetrad is an effect caused by the shape of Earth's orbit around the sun combined with the timing of eclipse seasons, and the sequence of tetrads varies over time.
For example, between 1582 and 1908, there were no tetrads. But there are 17 tetrads between 1909 and 2156. The previous tetrad occurred in 2003, 2004, and the next one won't start until 2032.
Okay, we've got our skies set up for Sunday night, September 27th at 9 p.m. Eastern Daylight Time. The moon will enter the penumbra at 8:10 p.m., but you won't notice anything exciting happen until just after 9 p.m. when the moon begins to enter the umbra.
Totality begins at 10:10 p.m. Eastern Daylight Time. Unlike the last 3 eclipses, everyone in the contiguous United States will be able to experience totality for this eclipse, from beginning to end.
Hallelujah! Now pray for clear skies though, because this is the last total lunar eclipse anyone will be able to see until January 2018.
The good news is that since the September 27th eclipse is in the early evening, there's no need to set your alarm clock.
Yay! So, happy eclipse watching!
And remember to keep looking up.